Hello and welcome everyone. Thank you for coming to this presentation. My today's talk is about planning for untangling, predicting the difficulty of merge conflicts. This is a joint work between Oregon State University and University of California, Irvine. So collaborative software development is one of the major driving forces nowadays. All large software projects are developed in a team. In 2017, over 4,000 individuals contributed patches to the Linux kernel. Windows Vista was developed by 3,000 developers in over 21 teams across 3 continents. And then more recently, TensorFlow in 2019 had 9,900 individuals contributing to it. Now, along with this collaborative software development, there are some negative side effects. Merge conflict is one such negative side effect. So what is merge conflict? A merge conflict is something that happens when multiple people try to modify the same piece of code simultaneously. For example, here you can see the picture on the top where we have a master branch and Alice and Bob both are trying to contribute to that branch. And both of them created their local branches and make some modifications. And at some point, both of them modified file F2. And then when they tried to merge it back to the master branch, they ran into a direct conflict on file F2. And on the bottom of the slide, you can see 2 ways of visualizing how merge conflicts is shown to the developer. On the left side, you can see how it's shown on GitHub. And on the right side, it's shown how the developers see it on the command line. Now, you might be wondering, why should we care about merge conflict? So the reason why we should care about merge conflict is it's a challenge for collaborative development. As soon as it happens, a developer actually has to interrupt the work and focus on solving it before they can move on with their work, making it an immediate concern for the developers. And of course, this is very common in terms of occurrence. Research actually shows that 1 out of 5 merge results in a conflict. And also, merge conflicts have impact on the quality. Impact in the sense that it's associated with long-term maintenance issues, and also it's associated with faults. Now, prior work has actually tried to investigate different effects of merge conflict and have tried to work on various aspects of it. On the right side, you can see a picture of the steps or the process that developers use for managing a merge conflict, which you can see has 5 different states. Now, prior work has looked into preventing merge conflicts and also have looked at early detection and helping with merging assistance. And also, researchers have looked into understanding the resolution difficulty, right? What makes a resolution difficult from a human's perspective. Now, in this work, we focus on predicting the difficulty of potential merge conflicts in order to help developers prioritize merge conflicts to inspect, accomplish more things given a tight schedule, and not waste reviewing efforts on trivial merge conflict resolution. Or in other words, we are trying to handle the problem of helping the developers in planning by automatic detection of probable merge conflicts, and of course, trying to identify what makes a merge conflict difficult. To be specific, in this paper, we address 3 research questions. How well can we predict the difficulty of merge conflicts? Which characteristics of merge conflicts are associated with its difficulty? And is cross-project training possible to predict difficult merge conflicts? Due to shortage of time, I will not go through the details of the steps that we deployed or used in this study. I will give a quick overview of the steps that were used. So we started with selecting a large number of projects from GitHub, 900 projects, and then we applied different kinds of filtering criteria that has been used in prior research. That ended up with 128 projects that was in our final corpus. Then we did the conflict identification, where we first started by extracting all the commit messages, which was around 556,000. Then we extracted the merge commits, which was around 36,000. Then out of those 36,000, we identified the conflicting merges, which was 6,380. Now on those merges, or on those merge conflicts, we collected process and product-related metrics that has been used or reported in prior work. In total, we identified 16 features belonging to 5 different categories. Then on those features, using those features, we built a machine learning model using the regular ML pipeline, where we did feature selection, model training, model evaluation, model comparison, and we finally made the final model. Then we did a cross-project prediction where we build a model on project A and then use that model for testing on project B. So what were our results? So first, we found that we investigated, can we predict the difficulty of a merge conflict? Yes. And we compared 5 different classifiers, machine learning classifiers, and we found that bagging actually can predict the difficulty of a merge conflict with relatively high accuracy or AUC value of 0.85. Now that we can predict whether a conflict is going to be difficult or not, the next obvious question is, what are the factors that makes it difficult? So what we did is we applied feature subset selection technique on the metrics that were identified or metrics that were used in the machine learning model that we used, which returned 10 metrics according to their importance. So as you can see, complexity is number 1 according to FSS technique or feature subset selection technique. So we also wanted to investigate whether the features that are identified to be important by the machine learning system is also similar with the features that are identified as important by humans. So for that purpose, we built on the work of McKee et al., where they identified features that were perceived to be important by humans when it comes to merge conflict resolution. So interestingly, what we saw that yes, in many cases, both feature subset selection and humans perceive the features equally importantly, like complexity. But also, on the other hand, what we saw is there are some metrics that are not that does not match with the human's perception. For example, dependency was identified as a important feature or one of the top important features by FSS. On the other hand, humans perceived it as less important. So we can see that conflict attributes have different importance based on the technique they are derived through. So this mismatch might be happening due to other factors, maybe lack of experience, or maybe there are many other aspects that needs to be investigated as part of future work. Then to answer our third research question, can cross-project training predict difficult merge conflict? Yes. And what we saw is cross-project prediction is possible with high AUC value, as high as 0.85 and 0.6 on average. So the implication of this, our work, is that we identified that it's possible to predict the difficulty of a merge conflict that is yet to happen. And we also saw that complexity, diffusion, centrality, size, all of these things matter when it comes to predicting the conflict difficulty, merge conflict resolution difficulty. Now, we stretched only the surface. There are so many other things that we have to investigate, like we are trying to improve the accuracy both within and across projects. And then, of course, identifying different thresholds that makes a trivial merge conflict to become a severe merge conflict. And then, of course, prioritize based on those thresholds so that the developers can pay more attention to the more difficult one and use that for speeding up the resolution process. Thank you, and thank you again for your attention.